Welcome to the presentation on database backup and recovery. In this session, we'll explore strategies for data protection and disaster recovery, ensuring your valuable information remains safe and accessible. Let's understand the critical importance of database backup and recovery. Firstly, it protects against data loss resulting from hardware failures. Secondly, it safeguards from human errors and accidental deletions. Thirdly, it ensures business continuity during unforeseen disasters. Finally, it meets regulatory compliance requirements. There are several types of database backups. A full backup is a complete copy of the entire database. A differential backup includes changes made since the last full backup. An incremental backup captures changes made since the last backup of any type, be it full, differential, or incremental. A transaction log backup records all transactions since the last backup. A robust backup strategy follows the 3-2-1 rule. Keep 3 copies of your data, the original and at least 2 backups. Use 2 different media, such as a local drive and a network storage device. Keep 1 copy off-site in a separate physical location. Regular testing is also important to verify backup integrity and restoration processes. Here is an example PostgreSQL backup script. Next, copy to secondary storage. Finally, upload to off-site storage. There are different tools used for database backup and recovery. For backups, MySQL dump is a logical backup utility for MySQL databases. PG_dump is a PostgreSQL backup tool for single databases. Oracle RMAN is a recovery manager for Oracle databases. AWS Backup is a managed backup service for AWS resources. For recovery, MySQL Client is used for restoring MySQL dump backups. PG_restore is a PostgreSQL tool for restoring PG_dump backups. Point-in-time recovery helps to restore the database to a specific moment in time. SQL Server Restore uses T-SQL commands for database restoration. Here is an example of MySQL backup and PostgreSQL backup. Here is an example of MySQL Restore and PostgreSQL Restore. Discussing some key recovery approaches. First, point-in-time recovery restores the database to a specific moment before a failure, using transaction logs. Full recovery is a complete restoration of the database using a full backup and subsequent incremental backups. Snapshot recovery allows restoration from storage-level snapshots for rapid recovery with minimal data loss. Standby or replica recovery involves failing over to a synchronized standby database with minimal or zero downtime. The key steps in the recovery process are to identify the failure point, select a recovery strategy, restore data, and verify the integrity of the restored database. Disaster recovery planning involves several components. A documented disaster recovery plan provides procedures for recovery after a disaster. A comprehensive backup strategy includes a schedule and retention policy. A secondary site provides an alternative location for database operations. A failover mechanism automates or manually switches to backup systems. A testing schedule includes regular validation of recovery procedures. Recovery point objective, or RPO, defines the maximum acceptable amount of data loss measured in time. Recovery time objective, or RTO, defines the maximum acceptable downtime until service restoration. Some of the best practices include: automate regular backups to minimize human error. Verify backups regularly by performing test restores. Secure backup data both in transit and at rest through encryption. Monitor backups in storage, setting up alerts for failures and issues. Document recovery procedures and test them periodically. Implement appropriate backup retention policies. Here is an example of backup verification script. There are various cloud backup solutions like AWS Backup, which is a centralized backup service for AWS resources, including RDS databases. Azure Backup is an integrated backup solution for Azure SQL databases. Google Cloud Backup provides automated backup for Cloud SQL instances. Cloud Backups offers key benefits, such as automated scheduling, geo-redundancy, point-in-time recovery, and encryption. However, considerations like data transfer costs, vendor lock-in, and compliance requirements should be considered. Here is a use case. A major e-commerce platform experienced database corruption during peak shopping season, affecting millions of customers and transactions. The platform implemented multi-tier backup strategy with hourly transaction log backups, daily differential backups, and weekly full backups. Geo-redundant storage across 3 regions were also implemented. As a result, there was a reduced recovery time from 8 hours to 35 minutes, minimized data loss to less than 5 minutes of transactions, and saved an estimated $2 million in potential lost revenue. In summary, there are key takeaways from this session. Implement a comprehensive backup strategy with multiple backup types. Define clear RPO and RTO metrics based on business requirements. Regularly test backup and recovery procedures to ensure reliability. Document recovery processes and train team members on procedures. Refer to additional resources such as database-specific backup and recovery guides. Use tools such as backup automation and monitoring solutions. Also attend training for disaster recovery planning workshops. Thank you. Questions? If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.